And the question is, what's the magnitude of the magnetic force acting on a 1.5 meter segment of wire number 1 due to the current in wire 2? Okay, and so we do this way here. So to find the magnitude of the force on a wire with a current in it, we use this guy here, the inside linebacker law. And so it's ILB sine theta. Now I is just the current, would be the 0.1 amps would be this current. So this would be I1. The length is just the 1.5 meters. Now for the B field, we've got to find the B field that's from wire 2. And so that would be this equation here. So it's B field from a current carrying wire looks like this right here. And so this would be U naught I 2 pi, and it would be this distance here, so we'll call R equal to 0.5 meters. Let's think about this. So first of all, this B field, if we do our right hand rule, if I do my thumb coming out with the current, my fingers kind of go around in a counterclockwise fashion. So the B field that's over here caused by 2, B field 2 points down, just to kind of help us out there. And so this would be U naught I over 2 pi R, that's a pi. And now finally, sine of theta. Now the theta is the angle that's between our B field and the current. And so here the current's coming out of the page, the B field's going straight down, so this angle for us is 90 degrees. Sine of 90 is just 1, and so we get that. And just be real careful for this current here, we should call it the current 2. It doesn't really matter because both currents are identical. And so when I'm all done with this equation, I get something kind of like this. I get U naught, I like to draw this U naught over 2 pi, and that's times current 1, current 2, L, everything on the top. And on the bottom it would just be R. Okay, and then if I plug in my numbers, so U naught divided by 2 pi is 2 times 10 to the negative 7. And then the I1 would be basically 0.1 amps. Now that'd be squared since there's 2 of them. The length is 1.5 meters. And then finally, you divide this by 0.5 meters. And when I did this, I got the answer A. And so finally, one thing we want to check on is just the direction of this force. Well, first of all, we know that when it's 2 wires in the same direction, the force is attractive. But I can also do this with my right hand rule. If my thumb goes out with the current out of the page, my fingers point down with B2, my palm points towards wire 2.